This presentation is delivered by the Stanford Center for Professional Development.
Well, good afternoon, everybody, and welcome to the Thursday, November the 1st, 2012 session in our series on green technologies in transportation. Thanks very much for putting up with my Skype intro last week from Sapporo, Japan. And I'm glad to be back with you in person because we can talk afterward and drink coffee and so forth. At the beginning, I do want to say a special word of thanks to Alan Miner, who has the Alan Miner Foundation, which has given us some additional financial support for this series. And the venture capital firm that he runs here in the Valley is called Sunbridge Partners. So you may see that on some of our information related to the series. Today, we're taking the other end of the spectrum from last week. Right? Last week we were talking about a crowdsourced sensor network that was giving information about environmental factors and traffic patterns in Beijing. This week we're going to talk about materials and a major development that's happened in the material world in transportation. If you go on United Airlines somewhere for your Thanksgiving or Christmas vacations, the president comes on at the beginning of the safety pitch, talking about the new Boeing 787 that United has bought. And the 787 is an incredibly efficient vehicle, and one of the major reasons behind this is the extensive use of carbon fiber composite materials. And these are developed and also commercialized by Toray, which has the world's Toray Industries, which has the world's leading market share for this kind of material. And we're very fortunate to have one of the key people who is involved in the development of these materials since the mid-1980s to come with us, to come from Seattle to give a presentation in our series just for today. He arrived this morning and has to go back on a 7 a.m. flight tomorrow. And so Mr. Toshiyuki Kondo is the president and CEO of Toray Composits America, which is located kind of right across the street from Boeing. And he joined Toray in 1985, right after finishing his master's in synthetic chemistry at the University of Kyoto. And at first he was doing technical R&D work on large-scale structure development. And from there, he became the general manager in charge of Torayka, which is the brand name for Toray carbon fiber materials, and was with the Advanced Composites Planning and Administration Department in Toray in Japan. Then he became general manager of the production department for Torayka, and since 2009 he's been in his current position with Toray Composites America. So let me turn over the microphone to Mr. Kondo. Thanks so much for coming down and giving us this talk today.
Good afternoon, everyone. I'm Toshiyuki Kondo, and thank you for the very kind introduction. And I really thank you very much for the giving me the opportunity to introduce our carbon fiber business today. Okay. So first, let me introduce our Toray group and our carbon fiber business, and how contribute the carbon fiber to the environment or transportation, efficient transportation. And Boeing 787, as Dr. Dasher said, that Boeing 787 extensively using our carbon fiber material. Almost 50% of structural weight is composed of carbon fiber. So I will touch about how we can achieve the very lightweight, efficient airplane with Boeing, and then conclusion. Okay, this is an outline of Toray Group. Toray established 1926, almost 85 years ago, as a rayon manufacturer. Toray, that name is abbreviation of Toyo Rayon. Toyo means Oriental, and rayon means rayon, chemical fiber. So Toray was established as a rayon manufacturer in 1926. And then we expand our business with fibers and textiles, plastics and chemicals. Those are kind of our foundation business. However, as you can imagine, fibers, clothing, textiles, or plastics, that those business are kind of mature business. So we need to expand in the different field like IT related products or carbon fiber and composite materials, together with life science or something like that. Our sales, consolidated sales, is almost on, let's see, 1,500 billion yen. This is 15, almost 15 billion dollars.
Yeah, 15 billion.
More than $15 billion, right?
Today's rate.
Maybe 20, almost, yeah, $18 billion. And this is a segment, sales by segment. Fibers and textiles and plastics and chemicals. Those are still our main business. However, we put lots of resources to expand those new business. This is our major product. I'm not sure you are familiar with Uniqlo. Uniqlo is a kind of apparel retailer of the United States, in Japan, and we are extensively, supplying this heat tech material, which has a function if this underwear absorb the water, it how can I say, generate the kind of heat. So very warm, even in the winter, we can, this underwear can keep the temperature, body temperature. Those kind of function allows us to, to go into the Uniqlo business, business with Uniqlo. So this winter, heat tech underwear Uniqlo will sell almost 100 million underwears in a year. And then other products. This is, I think, you are familiar with Sunships. The compostable or biodegradable bag. Toray, actually Toray Plastics America, located in Rhode Island, they are producing this bag, biodegradable bag. Other than that, we have interferon medical products. We are producing that. Then our carbon fiber materials, the extensively, as I said, Boeing 777 using our carbon fiber products. Toray is a material company. So our core technology or our base technologies are polymer chemistry or organic synthetic chemistry or biotechnology. We combine those technologies, then put our nanotechnology, with the nanotechnology, we have lots of, materials for the various products. This is also a kind of, our business, the change of our business fields. This is a rayon. We stopped the rayon business in 1960s. And fibers and textiles, resin and films, and new products like carbon fiber materials. Okay, let's change the topics to carbon fiber itself. Carbon fiber is, carbon. The fiber, since fiber, that means, very thin, long materials. So if we, let's see, if we go to the, I don't know, the yakitori restaurant or Japanese restaurant, you can see a charcoal. Charcoal is a kind, carbon. However, charcoal is this type of, shape. However, carbon fiber we call charcoal, but fibrous shape. So first, we make acrylic fiber. Acrylic fiber is used for blanket or sweater, artificial sweater or something like that. Those same fiber. And then we burn or we grill the acrylic fiber to make carbon fiber. But carbon fiber shows very superior performance if we compare with steel. Specific gravity, 1/4 of steel, very lightweight, and high strength, specific tensile strength, 10 times of steel, 10 times stronger than steel, and modulus, how durable for bending, 7 times of steel, and rust free. Those, very good performance makes carbon fiber to, use a lot of application. In 1971, Toray commercialized their carbon fiber as a world first producer. And carbon fiber applied to golf shaft in 1973. But we need a lot of time to expand our business. 2010, almost 40,000 tons of carbon fiber is used in the world. These are the application of carbon fiber. As I said, that with those advantages, carbon fiber can be used for airplane, automobile, ship, boat, bicycle, uranium enrichment, centrifuge, fuel cell, wind blade, or not PC, or CNG tank, or something like that. Those lots of application is the carbon fiber has been applied in various applications. So carbon fiber, since this is carbon fiber, with its lightweight, reduction of carbon dioxide emission carbon fiber can contribute to reduce of carbon dioxide emission or generation of clean energy or alternative fuel or others. Especially carbon dioxide emission, the reduction of carbon dioxide emission. This is a very, carbon fiber contributes a lot of carbon dioxide emission, reduction of emission reduction. So with several slides, I can explain how carbon fiber contribute to reduce the carbon dioxide emission. JCMA means Japan Carbon Fiber Manufacturing Association. Toray is one of the members of JCMA. And automobile, we choose model. For example, automobile, those are, the specification of the model of automobile. And this is a specification of model of airplane.
So JCMA is Japan Carbon Material Association?
Carbon fiber Manufacturers
Association.
Yes. And if we choose this model for automobile, mileage is 9.8 kilometer per liter. That means, let's see, 25 miles per gallon or something. And lifetime, 10 years. Automobile lifetime is 10 years. So, and almost 10,000 kilometers per year. So, in the lifetime, carbon dioxide is emitted during drives or flights, not the material production or assembly. Those are main portion of carbon dioxide emission. Since carbon fiber, let's see. As I said, that we burn or we grill the fiber to acrylic fiber to carbon fiber. So during producing carbon fiber, we use lots of energy. However, material production, the carbon dioxide emission in material production is only 12%. Drive or flight is a major portion to emit the carbon dioxide. And if we use the carbon fiber to the automobile, we can reduce the body weight from 1,400 kilogram to less than 1,000 kilogram. 30% reduction can be achieved by using carbon fiber reinforced plastics.
Yeah, that's a very important acronym that you'll hear more about in the future, CFRP.
Yep,
this carbon fiber reinforced plastic.
Yes. And if the airplane use the carbon fiber reinforced plastics, 20% weight reduction can be achieved. Actually, 787, this is a Boeing 787. The blue part, blue portion is carbon fiber. So main wing or fuselage or empennage or vertical fin, those parts is made of carbon fiber reinforced plastics. So 20% weight reduction can be achieved. So automobile, 30% weight reduction means 0.5 ton carbon dioxide reduction per car per year. So let's see. And also, airplane, 20% weight reduction means 700 ton carbon dioxide emission can be reduced. Let's see. So this is a let's see. So automobile carbon fiber, 1 ton of carbon fiber. If we produce 1 ton of carbon fiber, 20 ton of carbon dioxide was emitted. However, if automobile use 1 ton of carbon fiber, 50 ton of carbon dioxide emission is reduced. Means 30 ton of carbon dioxide can be reduced during the lifetime of automobile. So that means 19 million ton of carbon dioxide in 37 million automobile in the world. How about the airplane? Carbon fiber 1 ton, 20 ton carbon dioxide emission. That is same. However, if airplane use 1 ton of carbon fiber, 1,400 ton of carbon dioxide can be reduced. The huge. So that means from the viewpoint of LCA, life cycle assessment of those automobile or airplane, carbon fiber was considered as an environmental friendly material. Even though the production of carbon fiber, in the production of carbon fiber, they emit the carbon dioxide. However, if we can consider from the viewpoint of LCA, life cycle assessment, carbon fiber is very environmental friendly material. Okay, little bit change the topics. I think you can understand the carbon fiber is a very, mechanically the very superior material than steel, and also economically friendly, environmental friendly material. However, it took long time to get this point, 787. We need lots of, work together with, airplane manufacturer, Boeing. First, we commercialized the carbon fiber, and Boeing used our carbon fiber as a secondary structure, as kind of test. Secondary structure means if this structure broke, airplane can fly, even though this parts broke or fail, airplane can fly. That is secondary structure, like this is spoiler or flap or something like that. Those are not essential material, essential parts for the airplane. So Boeing first applied carbon fiber to the secondary structure for 757 or 767. Those are 1980s. And then Boeing first applied our carbon fiber to a primary structure of 777 empennage or those bars to support the fuselage. Those are primary structure. And in order to achieve the primary structure, carbon fiber, we have very big, breakthrough in technology. As you can see, this is an impact resistance. And this is the impact energy. Vertical axis is the impact energy. So conventional carbon composite, our CFRP, if big impact energy applied, impact resistance deteriorate very much. For example, maybe this is a carbon composite. If impact energy applied, this material easily break. That was a conventional carbon composite. So we can't use this kind of carbon composite like primary structure, because if something fell on the empennage, the empennage easily broke. It's not a airplane material. So we applied the energy absorbing material in the carbon fiber composite. Then we solved these issues. And then Boeing applied our carbon fiber to the 777 primary structure. After that, we put a plant in the United States. This is a carbon fiber plant, and we Toray Composite America. This is a resin impregnated seed product supplied to Boeing, and Boeing decided to use our Toray's carbon fiber to 777, for the all primary structure of Boeing 777. Then we also working together with next generation aircraft with Boeing. So not only the good performance of material, or and also we showed Boeing the carbon fiber is environmental friendly material. However, it takes 20 or 30 years to achieve the Boeing's decision to use carbon fiber extensively the primary structure. So let me summarize of the carbon fiber application for airplane. So 1982, 767, Boeing applied 767 carbon fiber. Carbon fiber is applied to Boeing 767 secondary structure, as a secondary structure, just 3% of aircraft. And 1995, Boeing decided to use carbon fiber as a primary structure for 777, 10 tons, almost 10 tons of carbon, 10 tons and 12% of structural weight. Then 787, 2010, primary structure approximately 35 tons. Almost 50% of structural weight was made by composite. 20% reduction. So in 40 years, after we commercialize the carbon fiber, we developed, or we have been studying to make stronger carbon fiber. In 1970, if we compared this, almost 5 times stronger than first commercialized material. Then Toray right now has almost 40% share of carbon fiber market. Since, as I said, that since material, it takes time to apply a new material to the good application. There are lots of American company has been trying to go into this carbon fiber market. However, they gave up. Almost all companies gave up this, since it takes time to, expand the business. So currently, Japanese 3 producers, Toray or Toho Rayon, Mitsubishi Rayon, has the lead in carbon fiber business. This is a current situation of carbon fiber. Okay, this is my thought to get innovate on the successful innovation, or to realize the innovative material. We need a technology, or we need as well as management. Technology, we need to have a establishment, or we need to establish world #1 position in core technology. And then we need to put effort for continuous development. For example, new material takes time. However, it is unable to make revolutionary aircraft, Boeing 777, without new materials. That is, Boeing 777, Boeing calls Dreamliner. But that is not just a Boeing's dream, Toray's dream. We dreamed to make a carbon fiber airplane. So Boeing 777 is kind of realization of our dream. And management, we need. I think the management. We need the management with a long-term vision. 30 years, and continuing and diligent investment for technical development. So we need to, management has to be very how can I say? Anyway, so management need to put continuing and diligent investment. So our carbon fiber business was in the red ink for 30 years. So that's why, other producers gave up during the this development. So new material takes a long time to get certification. So we need to endure that kind of time. Okay, this is my last slide. So we really believe that carbon fiber will expand the application. But key points, the cost reduction. The carbon fiber, the price of steel is almost $10. $1 per kilo or something like that. But carbon fiber price is more than $10 per kilo. So we need to make effort to reduce the cost continuously. Of course, carbon fiber has a superior performance. However, still, in order to make the carbon fiber the main material or main, material we need to reduce the cost, production cost, as well as total cost by, collaboration with the airplane company or automobile company. And also, we need to look for the new type of demand, automobile or aerospace development. SpaceX using a lot of carbon fiber right now. So we really hope to expand this application. Okay, that's my presentation.
Yes, thanks very much.